on machine M3, okay, is is need to be greater than equal to largest processing time on machine M2. Largest processing time on M2. That is the two condition. Okay, if either one of the in both condition, either one condition is satisfied in the both and both are satisfied. Okay, the given problem can be solved by Johnson algorithm as we solved in the previous lecture. That is nothing but the Johnson problem. Okay, Johnson algorithm that deal with the two machine end job. So that is the condition you need to satisfy. Then we can convert the problem. Okay. So try to solve. Just we try to solve this problem. Three machine and job. Okay. And let's see what is it. I think some noise is created. Okay. So how to solve this problem? First, you need to check the both the condition is satisfied or not. Okay, then we can go for the if any one condition satisfied, then we convert our problem into the two machines end job. Okay, so what is the first condition? So first in solution, check for the condition satisfied. Just I need to change the color. Check for the condition satisfied. Okay. So there, first you need to calculate the minimum processing time on machine M1. Minimum processing time on machine M1. Okay, here M1, M2, M3, three machine are there. Okay, they provide ABC. Three machine are there. Okay, so instead of one, you need to write machine A. Okay, I write here machine A. That you need to find out. Okay, next one, what is the, as per the condition, we need to find out the maximum processing time. Here this one is the minimum. Now maximum processing time on machine M2 MB. Okay, next again you need to you need to find out the minimum processing time on machine MC. Okay, so there is the ABC three machine, and what is the condition? As we discussed, the condition is like that. You need to satisfy one condition, then you can convert your problem into the two machine. Okay, so as we discuss here, the smallest processing time on M1 should be greater than equal to largest processing time on M2. That is the condition number one. And condition number two is like that: the smallest processing time on machine 3 is greater than equal to largest processing time on M2. Okay, so that is the condition we need to satisfy. So I just go here. Okay, and check first condition. What is the minimum processing time on machine A? Minimum processing time in machine A, class. What is the minimum processing time in machine A? It is 3. Okay, so I just write down here 3. Next, maximum processing time. Maximum processing time on machine B, maximum processing time on machine B is nothing but 5. Okay, so just write down here 5. And minimum processing time on machine C, the minimum processing time on machine C is nothing but how much? 5. So I just see what is the condition here. First, the condition number 1. What is the condition 1? Minimum time on machine A, minimum time on machine A, okay, should be greater than equal to maximum time. That is the condition. Okay, maximum time on machine B. That is the one condition as per the Johnson. Okay, so here minimum time on the machine A, that is the 3, okay, is greater than equal to the maximum time on machine B is equal to 5. So that is not satisfied here. Okay, not satisfied. So condition 1 is not satisfied. Let's see for the condition 2. Condition 1 is not satisfied. Okay, just check condition 2. If both are not satisfied, then we can't do the sequencing here. Okay, so just check condition 2. Okay, condition 2, as per the condition 2, minimum time on machine C is greater than equal to minimum time on machine B. Okay, just check what is the minimum time on machine C is equal to 5. What is the maximum time on machine B is equal to 5. So the condition is satisfied or not? So you can say yes, 5 is greater than less than equal to 5. Yes, it is satisfied because both are equal. So we can say the condition 2 is satisfied here. So we can go for the Johnson's rule, okay, and we can convert our problem into the two machine type of the problem. Condition 2 satisfied here. Okay. Now hence the problem can be solved by problem can be solved by AND job three-machine algorithm. Okay, so that is just we need to check if we can solve this problem or not. For checking the means it is a feasible problem we can solve for the sequencing or not. For checking, there is the two condition, that is the condition 1 and 2. Condition 1 say that minimum time on the machine 1 should be greater than equal to machine time maximum time on the machine 2. Okay, and condition 2 says like that the minimum time on the machine C or machine 3 is greater than equal to maximum time on the machine B. It is I think maximum. Sorry, I wrongly written minimum here. In second condition, this one is always maximum. Okay, so both in two condition, one condition is satisfied. Okay, hence we can say we can solve this problem. That is just for the checking of the this feasibility of the sequencing. Okay, maybe there one question will be there on your MCQ. means what is the condition to convert, what is the condition need to satisfy to convert a 3 machine into the 2 machine type of the problem. So here the condition is written here. The smallest processing time on the machine 1 is greater than equal to the largest processing time on machine 2. Okay, and the condition 2 is the smallest processing time on the machine 3 is greater than equal to the largest processing time on the machine 2. If either one or both of the above state condition are satisfied, then the given problem can be solved by Johnson rule. Okay. So now we convert our problem. The conversion is the very easy. There is no, not a, so just wait. Yeah. Okay, so now they need to convert our problem. So we can convert our problem like that. Okay, I write down the general thing. Uh, how to convert? Convert and job three machine problem into and job two machine. Okay, and problem by assuming two function machine G and H. Two machine problem, we assume that by assuming two machines G and H. Okay, instead of three machine, we assume there is the two machine. And how to address that such that like G is the first machine. So how to write a value for Gi is equal to M1 I plus M1 M2 I. Okay, you need to add M1 plus M2, and here in this condition, if I talking about, then here machine is okay, that I will tell you. Okay, next one is the HI is equal to machine 2 I plus machine 3 I, and I is equal to 1 2 3 till n. So that is the condition, means you just need to add M1 M2 in one column, and next column we add M2 and M3. Okay, and then we get two machines, that is the G and H. Okay, and we try to find out the optimal sequence on the basis of the two machine and job. Okay, so I try to solve. First you need to satisfy one condition in out of two, and either both condition you need to satisfy, or any one condition satisfied, then we can go for this process. Okay, that keep in mind. Now our table is here. That is the here given, that is the job is the given here, A, B, C. Three machine is the given here. So how to convert it into two machine, that I quickly, okay, I quickly convert. Okay, so as per the written above statement, how to convert this? This is your three machine and job type of the problem. Now I try to convert here. I just wait. I insert one table there. Okay, how much is the total number of the job is 5. Okay, and you need to write first one is the job. Next one machine B. Assume that G and H two machine. Okay, because we convert our means three machine problem into the two machine. Okay, and here the total number of the job are 5. 3 4 5. So 5 we written here. So how to make this G here? What value you need to write? That here I discuss. Okay, means you need to add machine 1 value as well as machine 2 value then you will get a G value. And what is the H value? And H1 value means you can say that is a machine 2 1 in row, you can say in row 1 value, and machine 3 row 1 value. Okay, so that I try to solve here. I try to fill up this table. Just wait. This is small. Okay, I fill up here. Okay, then can you tell me what is the value for G? G is nothing but you need to add this two value. You need to add this two value. That is 3 plus 4 is equal to 7. How to convert 3 machine to 2 machine? You need to add both the value. 3 plus 4 is equal to 7. So just write down here 7. Okay, and how to calculate the H value for row 1? That is the 4 plus 7. 4 plus 7. Okay, if I go through the here, and what, how to calculate M2 plus M3? Okay, it's nothing but M machine B processing time for that particular job, machine C processing time. If you add both the values, then you will get H column H value. That is the 4 plus 7 is equal to 11. Okay, can you tell me what will be the next value? Into 8 plus 5 is equal to 30. And 5 plus 9 is equal to 14. What will be the next? 7 plus 1 is equal to 8. And 1 plus 5 is equal to 6. What will be the next? 5 plus 2 is equal to 7. And 2 plus 6. 2 plus 6 is equal to 8. 4 plus 3 is equal to 7. If I made any mistake, then please let me know. 3 plus 10 is equal to 13. So now our problem, instead of this problem, is the 3 machine and job. We converted into the both the condition, and one condition is satisfied in our this numerical. So we can convert this problem into the 2 machine and job. Okay, so we converted here. Now, what is the optimal sequence you need to find out? That we know that how to find out the optimal sequence. The optimal sequence. That is the same procedure we apply for the two machine that you need to make here. Okay, so first you need to draw an array with the total number of the job 5. So with 5 boxes. Okay, here 5 is the total number of jobs. So here 1, 2, 3, 1, 2, 3, 4, 5. So that is our array. Okay, so now what is the procedure? That procedure means Johnson rule procedure. Already we discussed in the previous lecture. So what will be the first you need to find out? Can you tell me, class? What is the procedure to convert this 2 machine and job? Okay, we have that 2 machine and job table, processing time table. Now I need to find out the optimal sequence. So how to find out the optimal sequence, class?
Comparing the both G and H and lowest value at right side.
Okay. The thing is like that. You need to means first the minimum processing time in the 2 machine, both 2 machine. You assume like that here only 2 machine G and H. Okay, we converted our 3 machine and job into the 2 machine and job and behave like there only 2 machine. Okay, now the first procedure, as we discussed in previous lecture also, the first procedure you need to find out the minimum processing time on your table on your 2 machines. Okay, so what is the minimum processing time in whole table? Can you tell me what is the
Six.
minimum processing? 6. Yes, good. Okay, so here the minimum processing time is 6. Okay, and this minimum processing time is related to second machine, that is the H. Okay, if I assume that is the 2 machine and job, that it is related to second, so you need to put this job right side of your array. Okay, so I write here 3. Is there any doubt?
No, sir.
Because which okay, because 6 is corresponding to task or job 3. So that's why I write a 3 here in the right side of our array box. Okay, I write here, and it is related to second machine. So I write right side. If it is related to, suppose if it is related to means G machine, then we write here. Okay, so that is the, so I behave like that is not available in our table now, okay, because we put into the array that particular job. Now in reduced table, okay, in reduced table, can you tell me what is the minimum processing time? Class, in reduced table, can you tell me what will be the processing minimum processing time?
7.
7. Okay. 7 is available here, but 7 here in three positions, 7 is available for I, it is corresponding to task 1 as well as the corresponding to job 4 and 5. Okay, so which one I need to select first? Okay, so then you need to check corresponding another machine processing time, and if corresponding another machine processing time is minimum, you need to select that one first. Okay, so here if I check in first, here 7 is the minimum. Okay, then corresponding another machine time, that is the 11. Okay, here another machine time, that is the 8, and here 13. So we need to say select that minimum number which is corresponding there, means corresponding another machine time will be low in tie condition. Okay, so here this one is the low. Okay, so I select this one, this 7 first. Okay, and that I write left side. Why left side? Because it is related to machine 1, it is related to machine G. So I write down in left side of the array, in first of the first box of the array, that is the 4. Okay, and behave like that is not present in our table. Now next minimum, again there 7 in both the condition. Again the condition means as per the rule there is the tie. Okay, so now how to break that tie? By, you need to check another machine time that should be minimum. So here 11 and here 13. So we will select this one first. Okay, and it is related to machine 1. So you need to write in left hand side. And now in reduced table, what is the minimum
Sir,
time?
1.
Yes.
Sir, job 1.
Okay. Okay. Oh, sorry, sorry. That is the job. Thank you. Okay. Now the next, there is the 5. Okay, in 5 miss this one is the minimum. Okay, this one is the minimum. Okay, and corresponding okay, there no need to check because this is the minimum and there is no type. So just select this one, and it is related to machine 1. So you need to write here, that is the 5, and behave like that is not present. Now only one is remaining, that is the job number 2. So right here, and you can cross this. So now the optimal sequence is 4, 1, 5, 2, 3. Okay, that is your optimal sequence. Now if I check here, what is the question? Okay, there are 5 jobs, each of which is to be processed through 3 machine A, B, C. In order to A, B, C, time in hours are mentioned in this table, and determine the optimal sequence of the 5 jobs that already we found. Okay, now the minimum elapsed time, and also calculate the waiting time of time for 3 machines. Okay, so now I will calculate all the things. So I just need to make a one table here. Okay, and as we made a previous also. Okay, that table should be available in here. Then we can PPC, that is not one table is. Okay, so I try to make quickly one table here. Okay, just wait. That is related to, as we mentioned, that is the optimal sequence, as well as machine 1, machine 2, machine 3, and idle time for machine 2, machine 3. Just wait. This one table is available. Okay. Wait. Take a time. Okay, I try to make here only. It's take a time. Okay. What is it? To recover is not possible. Okay. That is available. Okay, so there only machine 2 is available now, but we have 3 machines. So I need to means remodify this thing. Okay, so how to remodify? I need to add machine 3 here. Okay, so I need to add 2 job means just wait. I insert 3 means left side, okay, right side. 1 left side. I quickly. So now this one is the machine 3. Machine 3 or machine C, okay, there they mention ABC in the form of the ABC. So you need to draw this table. Okay, this is the ABC in out time for all the machine. Okay, in out, and that is the your optimal sequence we need to write here now. Optimal sequence. Okay, so now this is our table. We need to make this table, okay, and we need to fill up this table. Then we can find out what is the elapsed time and what is the total idle time in the machine 1 and 2. Okay, so I just need cut here. Now we can make. So I just put here, okay, and I need to write, okay, I just small down so we can read all the thing here, okay. Now well, now we can read. Okay, so here the optimal sequence. Okay, I made this lot of column here. Just wait. Okay, the extra column is there, row is there. Okay, no issue. 4. Okay. The optimal sequence as we found, that is the 4, 1, 5, 2, 3. Okay, that is the extra column behave as a, that is not present here. Okay, so now There no need to buy. Here is your optimal sequence 41523. Okay, then just tell me what will be the in time of the machine A. If I asking about the job 4. Job 4 is the first we pass as per our optimal sequence we get okay on the basis of the Johnson rule. And here the job 4. If I talking about the job 4, okay, if it is not yes, yes. It is readable to everyone, class. This table is readable.
Yes, sir.
Okay, okay. So no issue. So as per the optimal sequence, that is the 41523, 41523. I write down the optimal sequence here in this table. Okay. So now I insert the job 4 first in machine A. Okay, and it is like that. First you need to do the drilling, then you can go for the after drilling you can go for the boring process, and after boring process you can go for the another process like threading process. Okay, so that is the three processes there. So now you can't escape any process, you need to follow this procedure. First you need to pass your product or you can say your raw material on machine 1, then 2, then 3, A, then B, then C, then you can make your final product. Okay, machine 2, and here also one I actually forget to add, that is the idle time on machine 3. Machine 3 also has some idle time. Okay, so what is the in time? That is here the 0 and the 5 is the total processing time of job 4 on machine A. So if I insert on 0, okay, here they mention 5. Okay, so what will be the value? Out when it will be out on time of 5 minutes. Okay, so that is the 5 unit of the time I need to check. Just wait. Mm. The processing time in hour they mention. Okay, so after 5 hours we will get this as a output. Okay, now this out we pass into here in machine B. Okay, and what is the processing time of job 4 on machine B? That is the 2. Okay, so 5 plus 2 is equal to 7, and after 7 hours we can pass into this one is on the machine C, and 7, and what will be the processing time there? That is the 6. Okay, so 7 plus 6 is equal to 7, 7, 6, 13. Okay, so can you tell me what will be the idle time on machine 2 and what will be the idle time on machine 3? Class? Can you tell me what will be the idle time on machine 2, or actually machine 2 not, there is the machine B, and what will be the idle time on machine C? Can you tell me? As per the optimal sequence I make all the thing. Okay, now I insert 4 job in machine A. Okay, then what will be the out time? That is the 0 and plus 5, because 5 is the processing time of job 4 on a machine A. Next one is the processing time is the 2 on machine B. So I insert this 5 because 5 after 5 hours only we can insert this on the machine B. Okay, so now 5 plus 2 is the processing time, so 7 is the out time. After B processing we can only do the machine C, means machine C processing. Okay, so 7 plus how much processing time there, that is the 6. So 7 plus 6 is equal to 30. So can you tell me what is the idle time for machine B and what is the idle time for machine C? If I talking about the job 4. Class.
5 and 7.
Yes, yes, yes. Good. Okay. So the first, if I talking about the idle time on machine B, then it will be okay. It will be 5, and here the idle time is 7. Okay, now you need to fill up for job 1. Okay, when I can insert the machine means the job 1 in machine A. Okay, so here after 5 it is free. Okay, so I insert on 5. Okay, then when it will be out. Okay, so I need to check the processing time of the job 1 on A, that is the 3. Okay, that is the 3 means in the it is a given data. Okay, so 5 plus 3 is equal to 8. 8 is the out time. Then this 8 we can insert here. Okay, so 8 insert here. Okay, now because on 7 it is free, so 8 we can insert. Then what will be the out time on machine B? If I asking about the job 1, then the time will be 8 plus 4, because 4 is the processing time. So 8 plus 4 is equal to 12. Okay, then when I can insert on machine C, can you tell me, class, when I can insert job 1 on machine C?
13.
Yes, 13. Okay, because machine C free will be free on 13 hour only. So this is the 13. Okay, then the processing time of job 1 on machine C is the 7. So 30 plus 7 is equal to 20 is the out time on the machine C. If I talking about the job 1. Okay, then what is the idle time on machine B? The machine B idle time. So here 8, and so 1 is the idle time here, and here no idle time, 0. Is there any doubt, class? Can I go for job 5?
Sir.
Okay. So now, when I can insert her, this will be free on after 8 hours. The machine A will be free. So 8 hours is the initial time of job 5, and the processing time on A is 4. So I need to add that 4 here, as so I will get out on 12 hours. Okay. Now when I can insert this one on 12, I can insert, because on 12 hour the machine B will be free. So I insert on 12. Okay, then out time of the job 5 on machine B. Here the processing time is 3. So 12 plus 3 is equal to 15. So just write down here 15. Okay, then when I can insert this on machine C on 20 only, because on 20 it will be free. Okay, so write down here 20. And what is the processing time on C? That is the 10. Okay, so out time is 30. Then what is the idle time on the if I talking about the machine B? Idle time of machine B is 0, and here the idle time is how much idle time?
0.
0. Good. Okay. Is there any doubt?
Sir.
Okay, so now I insert the job 2 as per the optimal sequence. Okay, when I can insert on 12 only, because after 12 hour the machine will be free. So I insert 2 here. Okay, on 12. Then when we will get as out. Okay, machine on machine A job 2, that is the 8 12 plus 8 is equal to 20. On 20 hour the job 2 will be out. Okay, that we will insert here. Okay, here the time on 15 it will be free, so we can insert on 20. Okay, then when we will get out this on machine B, so I need to check second. Okay, the processing time is 5, so 20 plus 5 is equal to 25. Now I can insert this one on 30 only. Okay, then when we will get out this one on the 9. 9 is the processing time. Okay, so 39. So can you tell me what is the idle time on idle time of the machine B and machine C?
5 and 0.
5 and 0. Good. Okay. So now on last one is the remaining, that is the 3. When I can insert these 3 on 20 only. After 20, the machine A will be free. Okay. Then processing time of the job 3 on machine A is 7. Okay. So 20 plus 7 is equal to 27 is the out time. Now this 27 we can insert here. Okay, on 27. Okay. Then the processing time of job 3 on machine B, that is the 1 hour only. So 28. Next one. This 28 I can pass on 39 only. And the processing time, that is the 5 as represent here. Just wait. Job 3 processing time on machine C is equal to 5. So 39, 5 is equal to 44. The idle time is 2 and here idle time is 0. And there no need to calculate the idle time for machine A because it is always 0. Okay. So can you tell me what is the elapsed time? Total elapsed time for our this problem. What is the total elapsed time? Class? The total elapsed time.
For machine
Yes, yes.
C. Sir, which
Yes,
one?
but
Machine B or machine C?
means no. Total elapsed time means to complete 1 to 5 all the job. What will be the time taken? Okay, as mentioned.
44.
44. Good. Okay. Determine the optimal sequence that we already determined. That is the for 5 job and minimum elapsed time means how much minimum elapsed time. If we follow this Johnson rule, then only we can get the minimum elapsed time. If randomly you allocate, then there will be value will be more than 44. Okay. So here the total elapsed time is the 44. In 44 hours, our all job will be completed on machine A, B, C. Okay. So that is the total elapsed time. Total elapsed time. Okay. That is the total elapsed time. And what is the idle time? Okay, I need to write here because that looks good. Total elapsed time is equal to 44 hours. Okay, and next idle time on machine B. Total idle time. You need to write. Okay, total idle time you can write. Is equal to 5 plus 1 is equal to 6. 5 plus 1 is equal to 6 plus 5. 6 plus 5 is equal to 11. 11 and 2, 13. So total idle time on machine B is equal to machine B is equal to 13. 13 hours is the idle time. Total idle time on machine C is equal to 7 hours. Okay. So as mentioned in this question, we found all the things. Okay. Determine the optimal sequence for 5 jobs that we found, and as minimum elapsed time that also we calculated. Now also calculate the waiting time for 3 machines that we already calculated. Waiting time is nothing but the idle time. Okay. So is there any doubt, class, how to solve such type of the problem, 3 machine problem, 3 machine and job? That is the last part of your sequencing. Okay. Means now our sequencing is done. Is there any doubt?
No, sir.
Okay, just wait.